All right, last video for the light and optics unit, and this is beyond light. This is actually probably my favorite part of this. Light is this little teeny tiny fraction of the overall spectrum of electromagnetic radiation. There is really highly powered radiation, cosmic rays and things like that. And there's this is going to seem weird, but there's radiation traveling through you right now. It's just traveling through you as a wave, and you don't realize it, but it passes through you because, I can listen to a radio broadcast. I can have a radio receiver on one side of me and the radio tower on the other side of me, and it'll still pick it up. You need to have something pretty serious to block a radio transmission. And there are radio waves in the wintertime, especially. I am able to pick up radio transmissions from Edmonton, like 500 kilometers almost away. And a radio transmission can reach my vehicle so I can listen to the Oilers when I'm driving around town at night on 630 Ched. Good job, Ched. But those radio frequencies, the long wave ones, they can travel way farther and face way less interference. The more densely packed, more higher frequency wavelengths, they can't travel as far, except for in the vacuum of space where there's nothing to get in the way of them. But they are way more powerful and can, pass through stuff as well. But there's radiation traveling through you all the time. Okay, so overall, what we're going to be talking about is the electromagnetic spectrum. So the whole electromagnetic spectrum, from very long wavelength, very low frequency waves, all the way down here to shortwave radios and AM radios, and FM is higher intensity, and that's why I can't pick up an FM channel from Edmonton. I know driving away from Edmonton, I can listen to whatever radio station I want to listen to from Edmonton to Sangudo, maybe on a good day, but they travel way less distance. Radar, if your parents have gotten a radar ticket or something like that. Microwaves are higher frequency, but they're like a specific frequency that vibrates the molecules of water. I'll put up a really fun video on microwaves. All the way up here to infrared light. Infrared, or IR, is lower energy than the red end of the spectrum, but it's just not something that our eyes are able to pick up. Then there's the visible light spectrum, which is this teeny band of radiation that our eyes are tuned to pick up. All the way up here above it, so here's violet, and then we have ultraviolet, which is higher frequency, shorter wavelength, higher frequency than the violet light that we see at the end of the spectrum. Up to X-rays. We've all probably at some point in time had an X-ray done of us where they put us down on a table and they send X-rays at our body to see if it's broken or if it's just a bad sprain or whatever. X-rays are really cool, but they're radiation. And that's why when the X-ray tech goes to, give you an X-ray, they stand behind that barrier, which is a lead barrier, to block the X-rays from possibly, hitting them and giving them higher than normal doses of radiation. All the way up here to gamma rays, and gamma rays and solar radiation are extremely high frequency, extremely damaging. These guys here, if you've heard of like the Chernobyl disaster, lots of people died and had birth defects and things like that as a result of the Chernobyl disaster. This is the extreme other end of the spectrum, literally. That's funny. Anyways, so infrared, I already kind of talked about this. These are like, if you guys have in your bathroom one of those red warming lights, that's what this is. Infrared light is just, it's just warm light. It's light that is below red, and we can pick it up and it feels nice and warm. So these heat lamps and those kinds of things are infrared. And you are putting off, so when you see night vision or infrared imagery where you can see the heat coming off of you, that camera is actually just picking up the radiation that you are emitting. And I realize that there's someone at home freaking out a little bit that they are putting off radiation. Don't freak out. We all put off radiation, it turns out. So radio waves are really low frequency, really long wavelength radiation, and we can use that to transmit information around the world. Your GPS system is using radio waves and those kinds of things to send signals all around the world. You pick up a phone call, and if you're calling someone on the other side of the world, that radio wave was sent to a satellite and then bounced back down to another tower in the other part of the world, and that information is traveling at the speed of light because of this radiation traveling between the two towers and the satellite. It's really cool. And this is going back and forth over and over again, and you don't even realize that it's happening again. It's all over the place. I'm gonna put up a whole bunch of videos on the full electromagnetic spectrum. It's really cool. Radar sat, being able to go and scan, they've discovered all sorts of things that we can't see with the bare eye, even from planes when they fly over things. But radar satellite is literally Landsat. They're sending signals down at the earth and trying to scan to see where different mineral deposits are, or where different geographic formations, barriers are, and those kinds of things. Just super cool stuff that happens as a result. We talked about cat's eyes being able to see at night. Ultraviolet radiation, UV. I'm going to put up, again, sorry, I realize I'm saying this a lot. I'm going to put up a really cool video about sunblock and those kinds of things. But UV light is what is giving you a tan in the summertime, when the summer does eventually come and the snow eventually melts, and we're able to go sit in our backyard on our decks and soak up the sun rays, but not interact with people because we're social distancing still probably. But that UV light that you're supposed to put sunblock on for, so that you don't possibly get something terrible like skin cancer, because it's still radiation. UVA and UVB is hitting you, and they're higher energy waves than the light that your eyes are able to pick up. You don't see it, but it's still there, and it's giving you your suntan. The ozone layer is there to block most of it, but it does not block all of it. And that's one of the things, when this textbook was made, there was thinning of the ozone layer as a result of things like chlorofluorocarbons, which were problematic for the overall running of ecosystems. The ozone layer has been repairing since we stopped emitting so many CFCs, but there are still some rays that get through. We have an entire, our Earth's magnetosphere is what it's technically called, is something that is actually projected. It's our magnetic, it's just a magnetic shield basically that protects the Earth from lots of the harmful rays that the sun puts out. So it actually blocks the really harmful gamma rays that our sun puts out and lets them bounce back off into space. But it lets through the lower frequency ones. Some of them, like light, are not a big deal. Our sun is putting off radio waves, and they're not a big deal. We can find out information about our sun as a result of some of the things that it puts out. Some of the stuff, though, we don't want to be bombarded with. So the ozone, ozone is 3 oxygen particles bonded together. The ozone protects us. It bounces the harmful rays out and keeps the good rays in, or lets the good rays in, I guess. X-rays, this always, every year there's some kid that sees this picture and oh my gosh, it's not a big deal. Yes, that is a pretty bad break. That's going to be a long time to heal. But those breaks, the reason why they can see that is they actually bounce X-rays, which are high frequency radiation, off the bone, and it goes through the muscle tissue in the skin, which you can kind of see there. It only bounces back a small amount, but it bounces, the bone is a very special frequency of that radiation. The bone actually bounces it back, and we're able to pick up that radiation on a sensor on the other, on the same side that we're emitting it from, and it's able to go and say there's a fracture or a break or whatever in this place. I'm sure they didn't need an X-ray to see that this was a break, but they would have used it anyways. And gamma rays, these are the really dangerous ones. When we dropped bombs on Hiroshima and Nagasaki at the end of World War II, we bombarded those cities with high frequency, really, really, really dangerous, powerful radiation. I will put up a really interesting video on these things as well. I have a couple of friends of mine who've had cancer and have had radiation therapy, which they actually took just little pieces of basically radioactive filings and put them around the tumor that they wanted to go and kill, and the radiation made it so that nothing around that could live anymore. By no means is that good for you. It's just better than the cancer that would kill you. So, really, some really crazy stuff that comes out of this. But those are the extreme ends, and I'm going to put up, again, a bunch of videos that are going to be associated with this that you will find educational and I hope interesting. So that, guys and girls, is the end of this unit called Light and Optical Systems. I will probably put up these questions for you guys to do, and there's a whole bunch of vocabulary. Me and Mr. Dirksen will see what we want you guys to do with this. Until next time, see ya.